Hello, good evening everyone. I hope you all are fine. So in the previous class, we have seen it's prayer time. We wait for book notes. Times. So in the last class, we have seen the 2 marks question. So in today's class, we will see 8 marks questions. So I'm sharing the screen. I hope it is visible to you. So in the last class, we have seen the problem. So now we will see briefly explain common clay minerals in soil and their structure. So clay minerals have two basic structural units, that is tetrahedral unit and octahedral unit. So how you will define tetrahedral unit? The tetrahedral unit consists of a silicon atom at the center surrounded by oxygen atoms at the four vertices. It is represented by a trapezoid. So tetrahedral unit basically consists of a silicon atom at the center surrounded by oxygen atoms in the four vertices. It is represented by a trapezoid. Octahedral units. Octahedral unit has either aluminum or magnesium at the center, with hydroxyl occupying the six vertices. It is represented by a rectangle. So the common clay minerals are as follows. Kaolinite. This is the most common clay minerals of kaolin. The structural unit is made up of gypsum and silica sheets arranged one above the other in the form of pyramid. It is found when the ratio of silica to aluminum ratio is very low. Montmorillonite. This is the most common mineral present in expensive clay soil. It is 2:1 clay mineral and very active. One gibbsite site is centered between two silica sheets. Soils containing montmorillonite clay minerals exhibit high swelling and shrinkage characteristics. Elite is similar to montmorillonite, but they have potassium ions in between the structural units. But they are more stable than montmorillonite. It is 10 angstrom thick. There is about 20% replacement of silicon for aluminum in the tetrahedral unit. Differentiate between compaction and consolidation. What is compaction? Compaction, expulsion of pore air, whereas consolidation is expulsion of pore water. So here in case of compaction, what is happening? Expulsion of pore air is taking place. Whereas in case of consolidation, expulsion of pore water is taking place. And soil involved is partially saturated. Case of compaction, the soil involved is partially saturated, whereas in case of consolidation, the soil is fully saturated. In compaction, it is applies to cohesive as well as cohesion less soil. Compaction, it is applies to cohesive as well as cohesion less soil. Whereas consolidation applies on only cohesive soils only. Compaction brought about by artificial or human agency, whereas consolidation brought about by application of load or by natural agencies. Dynamic loading is commonly applied, whereas in consolidation, static loading is commonly applied. Improved bearing power and thermal characteristics. In consolidation, improves bearing power and characteristics. Relatively quick process, insulation is slow process. Is used in embankment or urban, it is used in foundation. What are the effects of compaction on the soil properties? The effect of compaction on the soil properties are as follows. Changing structure of soil. Changing structure of soil. Soil properties are as follows. Change in structure of soil. The coarse grain soil maintain a single grain structure at any possible works ratio or water content, whereas these soils are not complicated occurs with respect to their structure. Permeability as the compaction effects increases, its permeability of soil decreases. Because of the increase permeability, as the compacting factor increases, the permeability of soil decreases. Because of the increased dry density and better orientation of particles. Shrinkage for the same density, soil compacted dry optimum shrink less than the sample compacted bed of optimum. Swelling. Clay soil compacted dry optimum exerts greater swelling pressure and swell to higher water content than the sample of the compacted bed of optimum. Explain hydraulic gradient. Explain hydraulic gradient, seepage velocity, superficial velocity, and coefficient of percolation. So how you define hydraulic gradient is the rate of change in hydraulic head water pressure per unit distance in the direction of flow. So how you are defining hydraulic gradient? It is the rate of change in hydraulic head water pressure per unit distance in the direction of flow. Seepage velocity it is defined as the rate of discharge of water per unit cross-sectional area of voids perpendicular to direction of flow. So superficial velocity is defined as the velocity of flow or the rate of water through the soil mass after entering in and emerging the soil mass after entering and emerging out of the total present in the soil mass. Coefficient of percolation. The rate at which water moves through a soil profile, often measured in terms of volume of water passing through a unit area per unit time. It's K equal to V into K equal to V divided by A into T. So what is a flow rate? Explain its characteristic. A flow rate is a graphical representation of two-dimensional steady-state groundwater flow through aquifers. So how you will define flow rate? A flow rate is a graphical representation of two-dimensional steady-state groundwater flow through aquifers. The characteristics of flow rate are flow lines are streamlines represent flow path of particles of water. Flow lines and equipotential lines are orthogonal to each other. A flow line cannot intersect another flow line. Flow lines are impermeable boundaries, and equipotential line cannot intersect another equipotential line. The discharge and flow channel is constant. So, what is flow line? We will understand what you can see characteristics of flow line. The characteristics of flow line. So, what is the flow line? Will it is a graphical representation of two-dimensional steady-state groundwater flow through aquifers. Flow rate, a graphical representation of the two-dimensional steady-state groundwater flow through aquifers. So, what are the characteristics of flow rate? Flow lines or streamlines represent flow part of particles of water. So, फ्लो लाइन जब स्ट्रीमलाइन से क्या मालूम पड़ता कैसा पाथ है पार्टिकल का वो मालूम पड़ता फ्लो लाइन्स एंड इक्विपोटेंशियल लाइन्स आर ऑर्थोगोनल टू ईच अदर जो फ्लो लाइन्स और इक्विपोटेंशियल लाइन्स हैं that are orthogonal to each other. A flow line cannot intersect another flow line. एक फ्लो लाइन दूसरी फ्लो लाइन से इंटरसेक्ट नहीं हो सकती. फ्लो लाइन्स आर impermeable boundaries. फ्लो लाइन्स क्या है? impermeable boundaries. An equipotential line cannot intersect another equipotential. एक equipotential line intersect नहीं हो सकती दूसरी equipotential line. The discharge in a flow channel is constant. Discharge है flow channel में constant. List and discuss the various factors affecting permeability of soil. क्या factors हैं जो कि affect करते हैं permeability of soil को? Number one, grain size. The permeability varies approximately as the square of the grain size. Since soil consists of many different size grains, some specific grain size has to be used for compaction. Permeability को क्या क्या factors affect करते हैं? First, permeability means what? Passage or seepage of water through the soil is known as permeability. तो किस factors पर depend रहते हैं? Grain size. किसका grain size? Soil का grain size. Permeability vary approximately as the square of the grain size. Since soil consists of many different size grains, some specific grain has to be used for compaction. Soil में अलग अलग तरह के grains रहते हैं जिसका size अलग अलग है. So permeability is directly proportional to square of size of the grain. तो uniform size grains use करना compaction के लिए. Second is effect of properties of pore fluid. The coefficient of permeability has the same value for all fluids and all temperature, as long as the Boyle's ratio and the structure of the soil skeleton are not changed. क्या है effect of properties of pore fluid? The coefficient of permeability has the same value for all fluids and all temperature, as long as the Boyle's ratio and the structure of the soil skeleton are not changed. How we are defining the effect of properties of pore fluid? The coefficient of permeability has the same value for all fluids and all temperature as long as the voids ratio and the structure of the soil are not changed. Effect of voids ratio. Effect of properties of pore fluids over effect of voids ratio. The laboratory experiments have shown that the factors of permeability changes very little with change in voids ratio of unstratified sand sample, but however it varies appreciably for placement. Saturated or structural arrangement of the soil particles, entrap air and form matter, absorb water in clay soils. Now we will see what do you mean by mass spring analogy. So this is the figure, spring, grain structure, cylinder, oil filled with water, while opening permeability of soil mass. The figure shows a spring with piston on its top placed in a cylinder containing water up to the bottom of the piston and a valve at its bottom. Water will be free of stress since the whole load is carried by spring alone. If the pressure on the piston is increased, the valve is closed. The spring cannot deform since water is incompressible. Hence, additional stress entirely borne by water. If sigma denotes the total pressure, U denotes the whole water pressure when sigma equal to sigma dash plus U. Sigma is 12, 10 plus 2, 12 minutes. Let the valve open slightly so that the water escapes and then the valve is closed. Due to escape of water, piston moves down. The spring is compressed and in some pressure borne by water is now transferred to the spring. So Q1 equal to 10 plus delta sigma dash plus 2 by plus now the valve is fully open. Water will escape the whole two units and the pressure is transferred for water to be spring. So Q1 is equal to Q1 plus 0 or sigma equal to sigma dash plus 0. So what are the assumptions made in Terzi's one dimensional consolidation theory? So the assumptions made in Terzi's one dimensional consolidation theory are the soil is homogeneous and fully saturated. The soil particles in water are incompressible. The deformation of the soil is due to change in volume. Darcy's law for the velocity of flow of water through the soil is perfectly valid. Coefficient of permeability is constant during consolidation. Load is applied in only one direction and deformation occurs only in that direction. Excess pore water drains out only in the vertical direction. The time lag in consolidation due to permeability of soil. These are the assumptions which were made in Darcy's theory. Now we will solve a problem. A shear vein of 75 mm dia and 110 mm length was used to measure the shear strength of soft clay. If a torque of 600 Newton meter was required to shear the soil, calculate the shear strength. The vein was then rotated rapidly to cause remodeling of the soil. The torque required in the remodeled state was 200 Newton meter. Determine the sensitivity of the soil. So vein diameter is 75 mm. If you convert this into centimeter to 7.5 centimeter, vein length is 110 mm. If you convert this to weight, 1 centimeter, torque applied at failure is 600 Newton meter. So it comes out to 680 centimeter. 2F is equal to T divided by pi d square h by 2 plus d by 6. T is found on 600 pi into D is 7.5, H is 11, D is 7.5. So 2 is equal to 0.503 kg of the slab. For remolded state, the shear strength will be in the direction of the torque. C sensitivity, C in undisturbed condition divided by C in disturbed condition. So your sensitivity is T in undisturbed condition divided by T in disturbed condition. S is equal to 600 by 2 and comes out to 3. Since sensitivity is in between 2 to 4, the clay is normal clay with the honeycomb structure. Sensitivity based on sensitivity, you can classify the soils also. So what are the advantages and disadvantages of direct shear test over triaxial shear test? Advantages we will see. The advantages of direct shear test over triaxial shear test are direct test is much quicker test to perform as well compared to triaxial test. Direct test क्या है? Time बचाता. Whereas triaxial test is time consuming. Second, it can be performed on both cohesionless and cohesive soil, whereas triaxial test can be conducted only on cohesive soil. So this is a limitation of triaxial test, that it can be done only on cohesive soil. It cannot be done on non-cohesive soil or cohesionless soil. Number three, the procedure is much simpler as well compared to triaxial test. So the procedure required for getting out direct test is very simple compared to triaxial test. Now it has some disadvantages. That is, direct shear test has some disadvantages. So what are those? Stress condition across the soil sample are very complex. जो stress की condition है across the soil sample, stress condition across the soil sample are very complex. Next, as compared to triaxial test, there is little control on the drainage of the soil. As compared to triaxial test, there is little control on the drainage of the soil. The plane of shear failure is predetermined. The measurement of pore pressure is not possible. So these are the disadvantages of that here over triaxial test. Now we will go to 10 marks questions. State Stokes law. What are the assumptions and limitations? So Stokes law states that the velocity at which the grains settle out of suspension and other factors being equal is independent upon the shape, weight, and size of the grain. So what Stokes law states? The velocity at which grains settle out of suspension, जो वेलोसिटी है जिसके मुताबिक ग्रेन्स बाहर आ रहे सस्पेंशन से, अगर दूसरे फैक्टर्स सेम है, other factors being equal is dependent upon the shape, weight, and size of the grain. So on what factors the velocity of particle moving in a fluid liquid differs? Shape, weight, and size. Assumptions of Stokes law. Soil particles are spherical. Soil particles can be spherical. Next, particles settle independently and neighboring particles do not have any effect on its velocity of settlement. So what are the assumptions of Stokes law? First assumption is soil particles are spherical. The soil particle is spherical. Shape of soil particle is spherical. Next, particles settle independently and neighboring particles do not have any effect on its velocity of settlement. Particles can settle only independently और उसका neighboring particles से कुछ effect नहीं है settlement का. The walls of the jar in which the suspension is kept do not affect the settlement. जो जार में सेटलमेंट हो रहा सस्पेंशन हो रहा इसका कुछ इफेक्ट नहीं है वेलोसिटी पे. So what is the limitations of Stokes law? In actual practice, the particle of the fine grain size are thin platelets, hence their movement cannot be to that of a spherical one. Actual practice में क्या हो रहा दो particles of fine grain size की thin platelets हैं, hence their movement cannot be that of a spherical one. The settlement of the particle influenced by sorting particles as the liquid is not of infinite extent. The particles falling near the wall of the jar are also affected as compared to particles away from the wall. See here, in the assumptions, we assume that the walls of the jar in which the suspension is kept do not affect the settlement, but the particles falling near the wall of the jar are also affected as when compared to particles which are away from the wall. So, one problem we will solve on Stokes law. Determine the time required for a soil particle to settle through a depth of 150 mm in a hydrometer test. Take mu is equal to 0.001 Newton second per meter square, G equal to 2.66, gamma W is equal to 9.8 kilonewton per meter cube, particle ranging size 0.6 mm to 0.02 mm of soil sample. So what are the things given to you? Capital H is given to us 150 mm. Depth mu is given to us viscosity, dynamic viscosity 0.001 Newton second per meter square. Specific gravity G is 2.66. Unit weight of water 9.8 kilonewton per meter. Diameter of spherical shape 0.67 to 0.02 mm. Particle size. T you need to calculate time. N is equal to mu by G. Mu is 0.001, G is 9.81. So N comes out to be 1.019 into 10 to the 4 Newton second per meter square. For particles of diameter 0.6 mm, we have from Stokes law, V is equal to 1 by 18 into d square into G minus 1 gamma W by N. 1 minus 18, D is 0.6, G is 2.66, gamma W is 9.8, N is 1.019 to 10 to minus 4. So V comes out to be 3.1929 meter per second. We know that V equal to H by T. V is 3.1929. H is 0.15 degree, so time comes out to be 0.046 second. For particles of diameter 0.02 mm, V is equal to 1 by 18 into d square into G minus 1 gamma W by N. So V is equal to 1 by 18 into 1002 square into G is 2.66 minus 1 into 9.8. N is 1.09 into 10 raised to minus 4. So your V comes out to be 3.5473 into 10 raised to minus 3 meter per second. We know that V is equal to H by T. We just now we have calculated it is 0.15. If you do the calculation, time comes out to be 42.2855. Now we will solve one more problem. A laboratory compaction test in a soil having G equal to 2.68 give maximum dry density of 1.82 gram per centimeter and the water content 17%. Find the degree of saturation, air content and percentage of air was and the maximum dry density. Also found the theoretical maximum dry density with respect to zero its time at optimum time. So what is the given data? Gamma D is equal to 1.82 gram per centimeter. W equal to 17%, equal to 0.17. G is 2.68. Gamma W 1 gram per centimeter. We know that maximum dry density gamma D is equal to G gamma W divided by 1 plus WG by S. So it comes out to 1.82, 2.68 into 1 plus 0.17 S. So your S degree of saturation comes out to be 0.9642 96.42%. Percentage of air was Na using the relation gamma D equal to 1 minus theta I G gamma W divided by 1 plus WG. Gamma D is 1.82, G is 2.68, gamma W unit water water 1 plus W water content 0.17, G is 2.68. If we do the calculation, it comes out to be 0.0115 or 1.15%. Next, theoretical maximum dry density gamma D equal to G gamma W by 1 plus WG. G is 2.68 into 1 plus W 0.17 to 2.67. So gamma D comes out to be 1.8412 gram per centimeter. Degree of saturation SR is equal to 1, data equal to 0. So distinguish between standard and modified Proctor test. Standard Proctor test uses 300 mm height of drop. Modified Proctor uses 50 mm height of drop. Rammer used in case of standard Proctor test is 25 Newton. In modified Proctor test 45 Newton. In standard Proctor test, 3 number of layers are there. Whereas in modified Proctor test, 5 number of layers are there. Energy is 60560 Newton per meter cube. Whereas in modified Proctor test, energy is 272,600 Newton per meter cube. Optimum moisture content is higher. Optimum moisture content is lower in modified Proctor test. Next, explain effective stress, total stress, and quicksand phenomena and neutral stress. So, what is effective stress? Effective stress or effective pressure is a pressure which is transmitted from particle through the point of contact through the soil mass above the plane. So how we are defining effective stress? Effective stress or effective pressure एक ऐसा pressure है जो कि transmit होता है from the particle through the point of contact through the soil mass of the plane. Total stress or total pressure is the total load per unit area at any plane in a soil mass. The load may be due to self-weight of soil or overburden of soil. Quicksand phenomenon. When water when flow takes place in an upward direction, the seepage pressure also upward direction, and the effective pressure is reduced. If the seepage pressure becomes equal to the pressure due to submerged weight of soil, the effective pressure is reduced to zero. In such case, the coival soil loses its shear strength, and the soil particles have a tendency to move upon the direction of flow. This phenomenon of lifting of the soil is known as quicksand phenomenon. Neutral stress. How you are defining neutral stress? Neutral stress or neutral pressure is a pressure that is transmitted through the pore fluid. This pressure is equal to water load per unit area above the plane and does not have zero influence on the Voigt's ratio and in the mechanical property. So I hope you understand the concept. The next class we will solve problem 8. If you have any queries, you can drop a message in the comment box. Or you can mail me at nadimedgar@cable.university, or you can call me during evening hours at my mobile number, that is 8553171859. So thank you for listening. I hope you all have a good day. Thank you one and all.